Hey guys, welcome back. Today we're going to be doing some word problems on applications of volume. Not too hard, hopefully. The good news is now that you all aren't taking the EOC, you really don't have to memorize all the formulas. And I think that's more real life anyway. So as long as you know that there is a formula that exists and you know which formula to use, I've always thought that's a whole lot more important than memorizing formulas. So I attached with this lesson today a reference sheet. Looks like this. If you can print it out and save it, and always refer to it anytime you need a formula regarding area, volume, surface area, that kind of thing. If you can't print it out, then take a picture of it and make sure you can get it anytime you need to in the future. Okay? So this is the reference sheet that I'm going to use from now on because, again, you don't really need to memorize formulas in life. You just need to know that they exist in the world and know when to use them. So today's examples, because they're word problems, you might struggle a little. I don't know. But if that's the case, I would recommend for each problem that I do a problem on the lesson, problem number 1, then you should pause the video and go to your worksheet and do problem number 1 because it'll be just like it. So watch one problem at a time and then do the problem that matches it in your work. So the first problem looks like this. Find the height of a cylinder if its volume is 382.6 cubic inches. So first, look at that reference sheet and figure out which formula is relevant to this problem. So it says volume right there, and this is a cylinder. Hopefully you know that. So hopefully you figured out that the correct formula for this is the volume of a cylinder. And when you do these problems, especially when you're working it backwards, you're not finding volume, you're finding something else like the radius or the height, make sure you always start by actually writing that formula, okay? Volume is equal to pi r squared h, which, by the way, that is the same as area of the base times the height because the base is a circle. All right, now it says the volume is 382.6. So replace the volume, this variable, with 382.6. Bring down the equal sign. Bring down pi, but I'm going to change pi to 3.14. The radius is 6. Square that, you get 36. The height is the unknown that I still don't know. Okay, so anytime you're working a problem backwards like this, you're only allowed to have one unknown if you want the problem to be solvable, and the unknown for this one is height. So now I'm just going to multiply these guys together, 3.14 times 36, which is 113.04. So bring down the 382.6 is equal to 113.04 h. To get h by itself, divide by 113.04 on both sides, and you really don't have to show that. You can just do it if you know what you're doing. And now h is by itself, so h equals whatever 382.6 divided by 113.04 is. Okay, and I get 3.384, but now I got to double check the directions. The directions say round to the nearest tenth, which means I'm now going to look at this 8. Since it's 5 or higher, I'm going to round this 3 up to a 4. So to answer their question, the height is approximately 3.4. And its height, which is just one dimension, so my units are just inches, 3.4 inches. So I would suggest you hit pause right now and do number 1 of your worksheet, which is going to be just like this. So the rest of these problems, this is number 2, the rest of these problems kind of involve two formulas at once. So just read the whole thing and pick carefully, pick out the things that are relevant to the problem, like so that you know which formula to use. So for this one, they mention surface area of a sphere and they mention circumference at the same time. So I'm going to need two formulas, one for surface area and one for circumference. So go to your reference sheet, find the surface area of a sphere, and hopefully that was this formula right here, and also find for a circle the formula for the circumference of a circle. Hopefully you found that to be this guy right here. So we have basically two formulas. We have to use the circumference formula, which is this guy, and the surface area formula, which is this guy. And honestly, it doesn't matter which one you write first. You're going to end up using both of them. So I'll just write the first one I think of without even reading the problem. Surface area is equal to 4 pi r squared. Circumference is equal to 2 pi r. Now reread the question and figure out what is the given information. There's only one problem or one number that's even given in this problem, and that's the 70. It says the circumference is 70. So you're going to replace the C right here with 70. So below circumference, replace the C with 70. Bring everything else down. I have a 2. The pi I'm going to replace with 3.14. And I have an r. Now I can solve for r because it's the one unknown. Multiply these two guys together and I get 70 equals 2 times 3.14, which is 6.28. Divide by 6.28 on both sides. And again, you don't have to show that. You can just do it if you understand what's going on. 6.28. The 6.28 cancels. So r is approximately, I got to put that in my calculator, 70 divided by 6.28. And I get about 11.146. Now be careful. You really don't want to round too soon. The number in my calculator is actually a lot more than that. It's got a lot more numbers going on. You don't want to round right now because I still have more to do with this problem. The problem actually asked for surface area. So you shouldn't round at this stage. You don't want to round until you get to the very final answer. So I wrote a rounded number here, but I'm going to keep that big number that's in my calculator, and that's the number I'm actually using. I'm just writing the rounded number so I have some sort of placeholder. All right, so now that I know the radius, the real question is what is the surface area? So now I got to take that radius and plug it in way up here for this r right here. So the surface area, which was the question, will be 4 times pi times the radius squared. And again, even though I'm writing 11.146, what I'm actually going to use is the number that's in my calculator. So now I can plug all of that into my calculator, 11.146, but use the big number that's in your calculator. Leave that number there with all those ugly numbers. Square it. Then multiply by 4 and multiply by 3.14. And then you're really supposed to round at the end. So now it says rounded to the nearest tenth. So I get 1,560.509, but if I'm going to round it to the nearest tenth, which is this digit, the 9 was irrelevant, and the 0 tells me to leave this 5 a 5. So my final answer is that the surface area is approximately 1,560.5, and it's surface area, so it's inches squared. Okay, so that was number 2. Hit pause and try number 2 on your worksheet. Number 3. This problem talks about a balloon, and a balloon, I assume they intend it to be in the shape of a sphere because they mentioned the circumference of it. So it's a balloon, so we're going to call that a sphere. And they give me the circumference, but they ask about surface area. So again, I need two formulas, one for surface area and one for circumference, and it doesn't really matter which one you write first. So referring to your reference sheet, I have two formulas I'm going to need. One will give me surface area and one for circumference. And just write them both down in either order. So, surface area is 4 pi r squared. Circumference is 2 pi r. Reread the question and figure out what's given. The only number given in the whole problem is the 27, and it's circumference that's 27. So replace the C with 27. So underneath that C, I'm going to replace that with a 27. Bring down my equal sign, bring down my 2. Replace pi with 3.14 and bring down my r. Now I have one unknown, which is the r, so I can solve for r. Multiply the 2 and the 3.14, which is 6.28, and bring everything else down. Get r by itself, divide by 6.28 on both sides. And again, you don't have to show that step, you can just do it. And I get that r is equal to 27 divided by 6.28. And again, that's an ugly number in my calculator. I'm going to write a couple of the digits down. 4.299, blah, blah, blah. There's more to it. Leave this number in your calculator. I wrote down a rounded value, but I'm really going to use the number that's in my calculator, and I'm not going to round until the final answer. So what they actually asked, I found radius in this problem, but they really want surface area. So now that I found the radius, I got to take this answer and plug it in for the r right here. So surface area will be, bring down the 4, bring down pi, and replace r with what we found, 4.299. But again, I'm really not using that number. I'm using the big, long, ugly number that's in my calculator. So from here, it's all in my calculator. Take that ugly number that's still in my calculator, square it, then multiply by 4 and multiply by 3.14, and I get that the surface area is approximately equal to 232.17, but what should I round to? Go back to the directions. It says round to the nearest square centimeter, and that means to the nearest whole number. So actually the 7 is useless. This 1 tells me that I'm going to round down and keep this 2 the way it is because the 1 is less than 5. So my final answer is that the surface area is approximately 232 centimeters squared. Okay, so reflecting back on that problem, for most of these problems, remember there's going to be two formulas, and you got to figure out which formula to use first is dependent upon what's given, what number do they tell you. Okay, and then you end up using both formulas in the end. Hit pause and do the next problem on your worksheet. Okay, so this problem talks about a hemisphere. A hemisphere is just half of a sphere. And it's a pretty straightforward problem. They just want us to find the volume. So if you look at your reference sheet right now, there's no formula for the volume of a hemisphere. So look for the formula for the volume of a sphere. And hopefully you found this to be the relevant formula. But it's not quite right because that's the volume of the entire sphere, and I want just half of that. So let's figure out what that would mean. For a hemisphere, I'm going to write the volume will be half of that formula, 4/3 pi r cubed. Now I can simplify that before getting even bogged down by the rest of the problem, and I can even write down my simplified formula will represent the formula for the volume of a hemisphere. And here's how you do that. The 4 and the 2 can both be divided by 2. 4 divided by 2 is 2. 2 divided by 2 is 1. Now if I multiply straight across, the volume formula will become 1 times 2 is 2 pi r cubed. Now on the bottom, 1 times 3 is 3, so it's 2/3 pi r cubed. Now if you want to add this formula to your notes, remember you're allowed to use your notes. So anytime they give you a hemisphere formula, this volume formula changes to being half of 4/3, which is okay. So this last one is another hemisphere, but it doesn't really say the word volume directly. So how do you know when you're supposed to figure out volume versus surface area? Well, the question here is, will the pond hold this much water? Well, how much water will fit in that hemisphere? That's the same as saying, what's the volume? What's the space inside that hemisphere? So we need volume again for this problem. And although the sphere formula is this is a hemisphere. And we just learned in the last problem that for a hemisphere, your volume formula, instead of being 4/3, it's 2/3 pi r cubed. Again, you don't need to memorize that. You can write it down right on your reference sheet. You're allowed to use your notes. Just know when to use which formula. Now I'm going to find the volume. The volume will be, I'm going to write the formula again, 4/3 pi r cubed, which is going to be 4/3, replace the pi with 3.14, and then the radius cubed. Well, the diameter that is given is 15. That's not the radius. So divide that by 2, and the radius is 7.5. Now, just like the last problem, all of this can go into your calculator. Just do the 7.5 cubed first. Wait a minute, I see a mistake. Do you all see the mistake? Look at my formula over here, and look at my formula over here. Slacker, I did not write the right formula. Let me fix that real quick. Time out. Change that to a 2. And change the next one to a 2. I like my sound effects. Okay, there we go. So when you go to do the math for this one, you're going to do the 7.5 cubed first, multiply by the top numbers, and divide by the 3. So all at once, my calculator, it's 7.5 cubed times 2 times 3.14 and divide by the 3. And I get that the volume is approximately 883.125. Now, read the question again. This answer that I got represents how much space I have in that bowl or in this pond. So this is how much the pond can hold. And the question is, could it hold this much? So yes, it could hold 879 cubic feet. It can hold up to this many cubic feet. I hope that went well for you guys. Good luck. It's really hard to see how much you understand because I can't read your faces like I normally do. But hang in there. You got this. Don't be shy. Let me know if you need help. Text me, email me, talk to your friends. Whatever I can do, let me know. Good luck. Your assignment, probably you've already worked through most of it now. It's worksheet 2. Good luck. Hope you're doing okay.